this chapter, we've looked at a lot of different integration techniques. But even with all the techniques we know, there are still some integrals that we haven't figured out how to do. And very often, they're similar to integrals that we do know how to do. Let's look at these. Okay, this integral is x squared times natural log of x minus x squared over 4 plus c. So now if the x is the denominator of a fraction, instead of being part of a product, then I get this. If I take this first integral and invert it, now my result is natural log of the absolute value of natural log x plus c. And then if I have x in the numerator and natural log of x in the denominator, I haven't learned how to do that one yet. We're going to look in this section at using some tables to do integration and also a couple of other techniques. Okay. In your textbook, in Appendix B, there is a very lengthy table of integration rules. These are some of the less common ones. And you might think, well, do I have to learn all those? No, you don't have to learn all those. You'll always have access to Appendix B when you're working problems. Okay? And if you've not figured it out by now, the process of integration depends a lot on your ability to recognize what kind of form you've got and how to approach it. So let's look at some problems that we can use the integration tables for. Okay, we can see that this expression under the radical is linear. So we should look for something that looks like this. In our integration tables. And we find it in formula 17. And we're going to look at the part where a is less than 0, since this is subtracting. Now, using formula 17, we're going to rewrite this integral as du over u times the square root of a plus bu. And that gives us an integral of 2 over the square root of negative a times arctangent of the square root of a plus bu over negative a, and then of course our c at the end. So in this problem, a is equal to -1, b is equal to +1, and u is equal to x. Okay, and if u is x, then of course du is dx. So our original integral, dx over x times the square root of x minus 1, is equal to 2, our tangent, square root of x minus 1 plus the constant. Here's another integral that we can use the tables for. Okay. In this problem, this has the form of u squared minus a squared inside the radical. Okay, and this should lead us to formula 26, which looks like this. The integral of u squared minus a squared du is equal to 1/2 of u times the square root of u squared minus a squared minus a squared times the natural log of the absolute value of u plus the square root of u squared minus a squared plus our constant. So in this case, we're going to let u equal x squared, since this is to the 4th. A is going to equal 3. If u is x squared, du will be 2x dx. And so you have this original is equal to 1/2 of the integral, the square root of x squared squared minus 3 squared times 2x dx. And when I simplify, I get 1/4 x squared times the square root of x to the 4th minus 9 minus 9 times the natural log of absolute value of x squared plus x to the 4th minus 9 in the radical plus the c. Okay, let's do one more integration using tables. This time a definite integral from 0 to 2 x over 1 minus 1 plus e to the negative x squared dx. Okay? I see this e to the x forming here. So looking at the formulas that have that, I decided to go with formula 84, which looks like this. Du over 1 plus e to the u is equal to u minus the natural log 1 plus e to the u plus c. So we're going to let u equal x squared negative. So du is negative 2x dx. So then I can take my original 0 to 2 x over 1 plus e to the negative x squared dx and rewrite it as the integral of x over 1 plus e to the negative x dx which is equal to negative 1/2 times the integral negative 2x dx over 1 plus e to the negative x squared. Okay, so when I integrate, I get negative 1/2 times negative x squared minus natural log 1 plus e to the negative x squared plus c. Okay, I can multiply those negatives through. So that's positive 1/2, positive x squared, positive natural log, and we're going to evaluate from 0 to 2 plus natural log of 1 plus e to the negative 4 minus natural log of 2, which is approximately equal to 1.66. So this goes here, and my equal sign goes here. Okay. In the integration tables, there are several integrals that have a form that we call a reduction formula, and it looks something like this. We'll start with the integral of x cubed sine x dx. There's 3 formulas that can help us with this. Let's write these formulas out. 52 looks like this. The integral of u sine u du is equal to sine u minus u cosine u plus a constant. This is formula 54. U to the n sine u du is equal to negative u to the n cosine u plus n times the integral of u to the n minus 1 cosine u du. And then formula 55 looks like this. U to the n cosine u du is equal to u to the n sine u minus n times the integral u to the n minus 1 sine u du. So if we start off with formula 54 and 55 and then apply formula 52, this is what we get. This is going to be equal to negative x cubed cosine x plus 3 times the integral of x squared cosine x dx. So we didn't make a big change, but we went from a cubic to a quadratic there. And now we can write negative x cubed cosine x plus 3 times x squared sine x minus 2 times the integral of x sine x dx. And finally, we get negative x cubed cosine x plus 3x squared sine x plus 6 cosine x minus 6 sine x plus c. So a lot of work, but we were able to come up with an answer. Here's another integral that we can solve using a reduction formula, or actually more than one. Okay, we've already used formula 17 once. We're going to use it again. This time we're going to use the part where a is greater than 0. And we're also going to use formula 19. So 17 looks like this. And then formula 19 looks like this. Okay, so there's the two formulas that we want to use. And in this problem, a is equal to 3, b is equal to -5, and u equals x. So we're going to take this 2 out, so I have 1/2 of the integral we just modify that a little bit, and now we have 1/2 times 2 square root of 3 minus 5x plus 3 times the integral dx over x times the square root of 3 minus 5x. Okay, and I can simplify that. The 1/2 and the 2 here cancel out. So this is just going to be the square root of 3 minus 5x. Plus I have a 3 here, and now I have to bring the 2 here. I can't cancel, so I've got 3 over 2 times the integral of dx over x times the square root of 3 minus 5x. Okay, we're going to continue with a equals 3, b equals -5, u equals x. But now apply formula 17. And so we're going to get our original is equal to square root of 3 minus 5x. We're not going to change that part. Plus the square root of 3 over 2 times the natural log, absolute value, square root of 3 minus 5x minus square root of 3 over square root of 3 minus 5x plus square root of 3 plus a constant. Okay, in the last example for this section, we're going to look at functions that involve rational functions with sine and cosine. So this is what we're going to start with. Sine of 2x over 2 plus cosine x dx. Now this would be much easier if instead of having 2x up here and x down here, if I had either 2x both places or x both places. So I'm going to change sine of 2x to 2 sine x cosine x. So now my integral looks like this. Okay. And when I look at the formulas that have cosine x and sine x, I don't find one that is really going to help me out. So instead of looking at sine x and cosine x, I'm going to look for forms that have a plus bu. And formula 3 seems to be one that will be helpful. And it looks like this. The integral of u du over a plus bu is equal to 1 over b squared times bu minus a natural log absolute value a plus bu plus c. So in this problem, we'll have a equals 2, b equals 1, and u equals cosine x. This means that du equals negative sine x dx. So now we have 2 sine x cosine x over 2 plus cosine x dx is equal to negative 2 times the integral cosine x times negative sine x dx divided by 2 plus cosine x. We can simplify this a little more and get negative 2 times cosine x minus 2 times the natural log of the absolute value 2 plus cosine x plus a constant. Distributing the negative 2, we get negative 2 cosine x plus 4 natural log 2 plus cosine x plus a constant. Okay, this example dealt with a rational expression that had sine and cosine in it. Okay, if I can't find an integral that fits my problem, there are some conversions that I can do. If I let u equal sine x over 1 plus cosine x, that's also tangent of x over 2. And I can get that cosine x is equal to 1 minus u squared over 1 plus u squared. Sine x is equal to 2u over 1 plus u squared, and dx is equal to 2 du over 1 plus u squared. Okay, proofs for these substitutions can be found on page 569 in your textbook.